I have a trampoline. I have a 50-pound bowling ball. And I have a handful of marbles. The trampoline is the analog for space-time. That's the thing that you and I and everything else in the universe shares. That's the one thing we are affected by. The bowling ball is the dark matter. Handful of marbles represents atomic material, planets, stars, whatever. Anything moving through space. So I put the 50-pound bowling ball onto the trampoline, and what is it naturally going to do?
Roll to the middle. Sink.
It affects the fabric, and it causes the trampoline to sink. When I take the marbles, if the bowling ball wasn't there and I toss those marbles out there, they're just going to go rolling in straight lines, according to Newton, forever. Things in motion tend to stay in motion unless something acts on it. Otherwise, they just keep right on going. So now when that marble rolling across the fabric of space-time, I want you to think about this. The marble is a lot like planet Earth or a locomotive. What does a locomotive not have? The steering wheel, because a locomotive only moves in straight lines. It's the line that does all the bending for the locomotive, and that's how it follows a curving path. The marble is doing the same thing. It only moves in straight lines. It's moving along the flat path of the trampoline until it encounters the part where the bowling ball is, and then it starts to do this. It didn't say, hey, turn left. It just started to do this because the line is compelling it to. So it's just doing this like planet Earth. If I pick up the bowling ball, this goes back into its normal straight motion again. Now, imagine that these marbles that I have, each marble represents an entire galaxy. When I put 100 marbles onto the trampoline, they're so little in weight. You can imagine I've got 100 of them, and I bunch them all together on the part of the trampoline. The problem is that the fabric itself, in our little experiment here, the fabric is too rigid. So the marbles don't represent enough mass to depress the fabric. So even though I try to coax them all together into one spot, unnaturally forcing them into a group, they're eventually just going to go flying off in every direction. But if I have that 50-pound bowling ball, thunk, then what are those marbles going to do? They're all going to roll into that place. We don't interact with dark matter, so those marbles roll right through the bowling ball, like a giant depression in space. They're oblivious to the bowling ball. All they're subject to is the depression. So they're rolling around in it. Dark matter is the bowling ball, and it's everywhere in space. If you think about this, imagine I have this very flat floor. Instead of a trampoline now, the flat floor with an infinite bucket of marbles. If I dump the marbles onto the floor, the marbles, like those galaxies, what we expect them to do is just simply go everywhere. But the floor is not flat, because a general relativistic explanation is that there's a landscape, there's a terrain. The terrain is defined by dark matter, but it makes it look in a way that we can intellectually understand. It's a series of mountain peaks and mountain valleys. And when I dump the marbles onto this floor, where will all the marbles go? Into the valleys. And you'll end up with giant rivers of marbles wrapping around giant mountain peaks. Very simple question. Where can the marbles not go? They don't roll up. So what you're looking at is a two-dimensional representation of space. And the landscape is visible. Now just imagine that the landscape is invisible. All you can see are the rivers of marbles. And now take it and make it three-dimensional. And now you have intertwining rivers of marbles stretching off in every direction. And that's what we see in space. Galaxies, billions of galaxies making long filamentary streamers. What's in between them? Giant empty bubbles in space, hundreds of millions of light years across. Those are the equivalent of the mountain peaks. Gravitationally, the galaxies don't roll up. They roll down, like water looking for their lowest point. Galaxies just simply flow into the fabric of space-time. The space-time itself is warped because dark matter is present. And if you want to understand what dark matter looks like, look at the filamentary structure of galaxies. They are the flower clinging to the invisible man. That's how we can tell it's there. Dark matter is the underlying gravitational scaffolding of the universe. Dark energy, which is even more of the universe, we know even less about. but I can offer you a very quick analog to help explain what it is, what it's doing, and what we see. The universe is expanding like a loaf of bread. A loaf of bread in that there's no particular place from inside the loaf of bread that you can determine. There's a center. You would think, everyone thinks that the universe is expanding away from a point, and that point is the center. But at no point in the bread dough baking does the bread dough declare itself, hey, everybody on the center, everybody move away from me. It doesn't happen because the bread dough is simply uniformly doing the same thing everywhere. All three dimensions everywhere throughout the bread. If it was packed full of raisins, the raisins would be analog for observers. I'm just going to grab two of them. These two raisins. There's a whole bunch of them, but these two are indicative of what every raisin sees. These two raisins are moving apart because the bread dough in between them is expanding. But what they observe is something different. This one looks at that one going, look at that dude, move away from me. Meanwhile, this dude is looking at that dude concluding the same thing. Wow, look at that dude, move away from me. Meanwhile, the bread dough is chuckling to itself saying, look at the two idiots. Because in reality, what's happening is they're not breaking out little arms and legs and burrowing to a new spot. They're just simply sitting there and the bread's pushing them apart. But it's uniform. So follow me. These two raisins are moving apart at 1 foot per hour. So are these two. So are these two. So are these two. And those two, and these two, and those two, and those two. Everywhere. Watch what happens. This raisin looks at that one and thinks, how fast is it moving away from him? 1 foot per hour. Following me? I need to hear it.
Yeah.
1 foot per hour. If you're here looking at this one's moving away at what speed? 1 foot per hour. If you're here looking at this one. Yeah! It's about how far you look. Because this gap is expanding 1 foot per hour, so is this gap. If you're looking from here to here, then it's 2 feet per hour. If you look from here to here, 3. From here to there, and if you can instantly teleport yourself to this position, you would just simply conclude that the other guy is doing the moving. Everybody sees the same thing. It looks like everything's moving away from you. Watch this peculiar effect. When you look further down the line, are they moving faster or slower? Faster. The further down the line you look, the faster and faster and faster they appear to be moving. Because they're not moving. It's the bread dough expanding in between the things. And the more you look, the greater the amount of expansion you're measuring. And so they appear to be moving faster and faster. What ends up happening is if you take this to its logical conclusion, what's the fastest you can go in the universe?
Light.
Speed of light. Space is big enough, which it is, and you can look far enough, which we can, and you should be able to look out there and see things moving away from you at the speed of light. And what would you see if you looked at things moving away from you at the speed of light? Nothing. Because the light never gets to you. And what you'd find yourself at is at the center of an event horizon. That's the edge of what you can see. And that edge is 47 billion light years away in every direction. Because the universe is just simply expanding away from us. But it's like being on a raft in the ocean. I'm here and the horizons are 17 miles away. I'm going to paddle over here. Am I closer to this horizon and farther away from that one now?
No.
No, it's exactly the same. Every observer on the earth sees exactly the same thing. Everyone's at the center of their own view. That's the only thing you're at the center of, your own view. And every observer on an infinitely large two-dimensional plane called the surface of the earth, no one's view is more special than anyone else's. Everyone's view is equally irrelevant. There's no central view. Everyone has the same view. It's just you're at the center of your own view. And that's it. And in the universe, it's the same thing. A couple of things. Silver buttons on the inside of your right armrest will allow you to recline into a more comfortable and potentially sleep-inducing position. Younger guests will find that they lack the mass to hold their seats back.
I can sleep sit down.
Sorry, can I ask you to turn off your devices, please? Your lights are very bright.